STA256 Assessment 3 presented to Madam Siti Aisha. We are from class CS1124D. Here are the table of our content. First, we have introduction of our team members. Second, we have problem statement. Third, we have question 1. Fourth, we had solution for question 1. Fifth and sixth, question 2 and solution for question 2. 7 and 8, we had question 3 and solution for question 3. 10 and 11, we had question 4 and solution for question 4. These are our team members. First, we have HIJJAZ bin HISHAM. And then, myself, Muhammad Taufiq bin Muhammad Radzuan.
This is our problem statement. It is stated that there is a group of researchers is to analyze survey data on and to construct confidence intervals to estimate population parameters such as mean and variance for both single population and comparison between two population. The data is given as follows. There is four sets of data that we will be using, which is gender, class, hours of studies, and test score, and there is 12 respondents.
For the first question, we have to estimate the mean of a population and construct a 1 minus a% confidence interval for these population parameters. For the question A, find a 95% confidence interval for the mean of a population, and for question B, interpret the results. The solution for question 1A is we started it by using gender and hours of study as the data to calculate its interval for the mean. We have identified that the alpha is 0.05, where we managed to obtain it from 1 minus 0.95, and we have also identified that the n equals to 12. We firstly calculate the x bar value by using the formula summation of x divided by n, and we achieve x bar equals to 17.25. We have obtained the value of s from calculator and we get 4.8625. Since variance is unknown and n is less than 30, therefore we will be using t-distribution to construct a confidence interval. We then will achieve a formula of x bar minus t alpha divided by 2 n minus 1 times s divided by square root n less than mu hat and mu hat less than x bar plus t alpha divided by 2 n minus 1 times s divided by square root n. We then obtain t alpha divided by 2 n minus 1 equals to 2.201 based on the statistical table. After substituting all values into the formula, we obtain 14.1605 less than or equal to mu hat and mu hat less than or equal to 20.3395. Next, to answer question 1b, we are 95% confident that the true mean score of the population lies between 14.1605 and 20.3395. For the second question, we have to estimate the mean of two populations and construct a 1 minus a% confidence interval for the mean difference of two populations. For the first question, which is A, find a 95% confidence interval for the difference in the mean of two populations. B, interpret the results. C, discuss your finding about the interval. The solution for question 2a is we started it by using gender and hours of study as the data to calculate its interval for the mean. We have identified that the alpha is 0.05, where we managed to obtain it from 1 minus 0.95, and we have also identified that the n1, which represent the number of male, is equals to 6, and the n2, which represent the number of female, is also equals to 6. We firstly calculate the x bar value by using the formula summation of x divided by n, and we achieve x bar 1 equals to 17.67 and x bar 2 equals to 16.83. We have obtained the value of sample variance 1 and sample variance 2 from calculator, and we get sample variance 1 equals to 25.0667 and sample variance 2 equals to 25.7667. Since larger sample variance divided by smaller variance is less than 3, therefore we will have to calculate SP. We will calculate SP by using the formula square root n1 minus 1 times sample variance 1 plus n2 minus 1 times sample variance 2 divided by n1 plus n2 minus 2. After substituting the values, we obtain the value of SP, which is 5.0415. Since variance is unknown, therefore we will be constructing a confidence interval and achieve a formula of x bar 1 minus x bar 2 minus T alpha divided by 2 n1 plus n2 minus 2 times SP times square root divided by square root of 1 divided by n1 plus 1 over n2 less than or equal to mu hat 1 minus mu hat 2 and mu hat 1 minus mu hat 2 less than or equal to x bar 1 minus x bar 2 plus T alpha divided by 2 n1 plus n2 minus 2 times SP times square root of 1 over n1 plus 1 over n2. We then obtain T alpha divided by 2 n1 plus n2 minus 2 equals to 2.228 based on the statistical table. After substituting all values into the formula, we obtain negative 5.6451 less than or equal to mu hat 1 minus mu hat 2 and mu hat 1 minus mu hat 2 less than or equal to 7.3251. Next, to answer question 2b, since the interval passes through 0, we can conclude that the two means do not differ significantly because the value 0 is included in the interval. Finally, to answer question 2c, the wide range of the confidence interval indicates a high level of variability in the hours of studies among male and female.
Question 3. Estimate the variance of the population and construct a 1 minus alpha percent confidence interval for these population parameters. Hence, A. Find a 95% confidence interval for the variance of the population. B. Interpret the result. Solution for question 3. First, we need to find the sample variance for test score, which is, after I calculate using calculator, I get 171.1515. We are given a sample size of 12, so our degree of freedom will be n minus 1 equals to 12 minus 1 equals to 11. We want to find the 95% confidence interval for the population variance. We start by defining our confidence level as 95%, which means alpha is 0.05. This alpha value will be used to find the critical values from chi-square distribution. We use the chi-square distribution to construct the confidence interval for the variance. The formula is the probability that the chi-square value with alpha over 2 degree of freedom is less than or equal to bracket of n minus 1 times the sample variance and divided by population variance. This is less than or equal to the chi-square value with 1 minus alpha over 2 degree of freedom and is equal to 1 minus alpha. At the line 3 of constructing this formula, you will see I added hat at the variance in the middle, which means that is the simplest form of constructing this formula. After you get the simplest form of constructing this formula, you just need to insert the value of alpha, the value of n, and the value of s to find the final answer. And the final answer will be the population variance is between 85.89 and 493.36. A 95% confidence interval of 85.89 and 493.36 for the variance of the test score means that we are 95% confident that the true population variance of the test score lies within this interval. Question 4. Estimate the variance of two populations and construct a 1 minus alpha percent confidence interval for the mean difference of two populations. Hence, A. Find a 95% confident interval for the ratio of variances for two populations. B. Interpret the results. C. Discuss your finding about the interval. Solution for question 4. As you can see at the table above, we had 7 data for class A and 5 data for class B. From the data above, we can find the variance of test score for each class. For class A, you will get 209.33, and for class B, you will get 126.8. We use the F distribution to construct the confidence interval for the variance. The formula we use is the probability of the value of f alpha over 2 and 1 minus 1 and 2 minus 1 less than or equals to f less than or equals to the value of f 1 minus alpha over 2 and 1 minus 1 and 2 minus 1 equals to 1 minus alpha. As you can see, at the line 5 of constructing this formula, I added a hat on sigma squared 1 and sigma squared 2, which means that will be the simplest form of constructing this formula. After you get the simplest form of constructing this formula, you just need to insert the value of s squared 1, s squared 2, alpha, n1, and n2. The final answer will be the population variance hat 1 over variance hat 2 is between 10.2849 and 0.1794. Question 4b. A 95% confident interval of 0.1794 and 10.2849 for the ratio of the variances between class A and class B test score means that we are 95% confident that the true ratio of the variances lies within this interval. Question 4c. Variance hat 1 over variance hat 2 equals to 1, which means that variance hat 1 are equal to variance hat 2. Therefore, we can conclude that two variances are equal as the value of one exists in the interval of estimation. That's
That's
all
all
from
from
us.
us. Thank
Thank
you.
you.